Hey there, future roboticists. Ever watched a self-driving car and thought, I want to build one? Well, guess what? You totally can, and it's going to be epic. We're about to dive headfirst into the world of AI and robotics by building our own AI-powered model car. It's going to be a wild ride, packed with learning, problem-solving, and a whole lot of aha moments. This isn't just about building a cool toy, it's about understanding the technology shaping our world. We're talking self-driving cars, delivery robots, and even spacecraft exploring the cosmos. By the end of this journey, you'll have the skills and confidence to tackle any robotics challenge that comes your way. So, buckle up, grab your tools, and get ready for an awesome adventure in the world of AI-powered model cars. Let's build something incredible together. Before we unleash our inner mad scientist, let's gather the essential ingredients for our AI-powered masterpiece. Don't worry, we're not building a time machine yet, so these parts are easy to find online or at your local electronics store. This is the body of your car. You can grab a pre-made one or get crafty and build your own. We need some muscle to get moving. 2 DC motors will do the trick for a 2-wheel drive system. This acts as the brain for our motors, telling them when to start, stop, and go faster. The heart of our operation, we'll use a powerful, yet beginner-friendly one like the Arduino Uno. No juice, no movement. A rechargeable battery pack will keep things running smoothly. These are the eyes and ears of our car. We'll need ultrasonic sensors for obstacle avoidance and a camera for navigation. These little guys connect everything together like veins and arteries in our robotic beast. Our coding playground for programming the microcontroller. It's free and easy to use. We'll use this versatile language to train our AI model and handle image processing. Think of these as pre-written code modules that make our lives easier. We'll need some for motor control, camera interfacing, and AI. That's our shopping list. With these tools at our disposal, we're ready to embark on our AI-powered car adventure. Time to get our hands dirty and assemble our robotic beast. Don't worry, we'll take it step by step, like putting together a super cool high-tech puzzle. First, we need to build the foundation of our car. If you're using a pre-made chassis, awesome. If not, grab your building materials and follow the design you've chosen. Make sure there's enough space for all our components. Next, attach the motors to the chassis. These will power our wheels and make our car go vroom. Connect the motors to the motor driver, which will act as their control center. Now let's mount the microcontroller, the brains of our operation, onto the chassis. This little chip will control everything from motor movement to sensor readings. Our car needs energy. Connect the battery pack to the motor driver and the microcontroller. This will provide the juice for all our electronic components. Time to give our car senses. Mount the ultrasonic sensors at the front for obstacle detection. Install the camera at the top, giving it a clear view of the road ahead. We've built our car. Now let's teach it how to move. This is where the magic of coding comes in. Using the Arduino IDE, we'll write instructions that tell the microcontroller how to control the motors. First, we'll write code to make our car go forward, backward, left, and right. We'll use simple commands to control the speed and direction of each motor. Now, let's make our car smart. We'll write code that reads data from the ultrasonic sensors. If an obstacle is detected, the car will automatically stop or change direction. Time to give our car vision. We'll use Python and a library like OpenCV to access the camera feed. This will allow us to see what the car sees in real time. Section 5. Eyes on the road, integrating a camera. With our car assembled and the basic code in place, it's time to give it the gift of sight. We'll achieve this by integrating a camera and teaching our car to see its surroundings. First things first, we need to connect the camera to our microcontroller. Don't worry, it's like plugging in a USB drive, just with a few extra wires. Once connected, we can start streaming live video from the camera. Here's where Python swoops in with its image processing superpowers. Using libraries like OpenCV, we can capture the video stream from the camera and break it down into individual frames. Think of it like flipping through a flipbook, with each page representing a snapshot in time. Now for the fun part, manipulating those images. We can teach our car to identify edges, detect colors, and even recognize simple shapes. It's like giving our car a basic understanding of its environment. Finally, let's display the camera feed on our computer screen. Seeing what the car sees in real time is not just cool, it's crucial for understanding how our car perceives the world and for debugging any issues later on. Section 6. The brain. Training your AI for vision-based navigation. Now that our car can see, it's time to give it a brain. We'll use the power of artificial intelligence to train a model that enables our car to navigate based on what it sees. First, we need to collect training data. This involves manually driving our car through a designated course, recording the camera footage, and corresponding steering angles. The more data we gather, the smarter our AI will be. Don't let the fancy name intimidate you. Convolutional neural networks, or CNNs, are simply a type of AI model that excels at image recognition tasks. We'll feed our training data into a CNN, allowing it to learn the relationship between what the camera sees and the correct steering angles. This step requires some patience. Training an AI model can take time depending on the complexity of the task and the amount of data. But trust me, the results are worth the wait. Once our model is trained, we need to evaluate its performance. We'll test it on a new set of data it hasn't seen before to ensure it can generalize well to unseen situations. Section 7. Merging AI and machine integration time. We've got a car that can see and an AI brain ready to navigate. Now let's merge these two components and create a truly autonomous vehicle. We'll use Python to bridge the gap between our trained AI model and the car's hardware. The Python script will receive the live camera feed, pass it through the AI model, and then send control signals to the microcontroller based on the model's predictions. The AI model will predict the optimal steering angle based on the camera input. This information is then transmitted to the microcontroller, which adjusts the motors accordingly, allowing the car to steer autonomously. We can also implement speed control based on the environment. For instance, if the AI detects an obstacle ahead, it can instruct the car to slow down or come to a complete stop. Integration often requires some fine-tuning. We might need to adjust the sensitivity of the steering or the thresholds for obstacle detection to ensure smooth and safe navigation. Section 8. Troubleshooting 101. Bugs beware. Even the most brilliant minds encounter bugs in their code. But fear not, debugging is all part of the fun. Here are some tips to squash those pesky errors. First things first, ensure all your hardware connections are secure. A loose wire can cause all sorts of unexpected behavior. Those cryptic error messages are actually your friends. They provide valuable clues about what went wrong and where to start looking for the problem. Don't be afraid to seek help online. Chances are, someone else has encountered a similar issue and shared their solution. When coding, it's best to test your code in small increments. This makes it easier to pinpoint the source of an error if one arises. Sometimes the best way to solve a bug is to step away from the problem for a bit. When you return with fresh eyes, the solution might become clear. Section 9. Unleashing your AI beast. Time for testing. The moment of truth has arrived. It's time to unleash our AI-powered car onto a test track and witness its autonomous navigation skills in action. Design your course. Create a challenging yet safe course for your car to navigate. Use tape, blocks, or other objects to mark out the path and create obstacles. Initial test run. Start with a simple course to ensure everything is working as expected. Observe how your car handles turns, obstacles, and different lighting conditions. Gradual complexity. As your car gains confidence, gradually increase the complexity of the course. Introduce tighter turns, more obstacles, and varying terrains to challenge its navigation abilities. Data collection. Continue to collect data during testing. This will help you identify areas where your AI model might be struggling and provide valuable information for further training and optimization. Section 10. Level up your ride, advanced enhancements. Congratulations, you've built an awesome AI-powered car. Now let's take it to the next level with some advanced enhancements. Explore other sensors like LiDAR or GPS to enhance your car's perception. LiDAR can provide more detailed 3D maps of the environment, while GPS allows for outdoor navigation. Dive into the world of reinforcement learning, where your car learns to navigate by trial and error, constantly improving its performance based on rewards and penalties. Add a remote control feature to switch between autonomous and manual driving modes. This gives you the flexibility to take over control whenever you like. Get creative. Personalize your car with custom paint jobs, LED lights, or even a miniature action figure driver. Section 11. The road ahead. Endless possibilities. You've done it. You've embarked on an incredible journey into the world of AI and robotics, and you've emerged victorious with your very own AI-powered car. But the journey doesn't end here. It's just the beginning. The field of AI is constantly evolving. Stay curious, explore new algorithms, and never stop learning. The more you learn, the more innovative your projects will become. Inspire others by sharing your project and knowledge with the world. Write a blog post, create a video tutorial, or present your work at a maker fair. Think about the real-world applications of your newfound skills. From self-driving cars to robotic assistants, the possibilities are endless. So, keep building, keep innovating, and never stop exploring the exciting world of AI and robotics. The road ahead is paved with endless possibilities.